Hello dear learners, we are continuing with our classes on trigonometry. Today we are going to see solution of triangles. Okay, in question 6 here, let's look at the question. AB is a vertical tower of P units high. D and C are in the same horizontal plane as B, the foot of the tower. The angle of elevation of A from D is X, BDC equal to Y and DCB equal to theta. The distance between D and C is K units. Normally in all these type of questions you will have a horizontal plane and a vertical something, a pole or a post, anything. So what we need to know is the angle between the vertical part and the horizontal plane is always 90, or luckily here it is marked. Sometimes it's not marked, then you must know that this is 90 degree. Okay, now let's go to the question and also have a idea about the sine rule and cosine rule. When we come to this question, you must also remember that sine rule is used when you have a sine rule. Okay, let me give you a note on that. Sine rule is used when you have two sides and one angle, or when you have two angles and one side. That's when you use the sine rule. And remember, this one, the one angle doesn't include the angle, not the included angle included, or the included angle. Okay, now the cosine rule is used. Cosine rule is used when you have all three sides given, all three sides. Then you use the cosine rule, or you use it when you have two sides and the angle included. Two sides and the included angle is given. That's when you use the cosine. You must have this in mind when we do solution of triangles. Okay, 6.1.1, express P in terms of dB and X. So you can see that P is in the top triangle ABD. So in triangle ABD, so here in triangle ABD, you can say using the P, we want P in terms of dB, this side. So according to the angle X, this is the opposite side and this is the adjacent side. We are saying opposite and adjacent because it's a right angle triangle. So the ratio with the opposite and adjacent side is, so for 6.1.1, you can use a ratio tan of angle X is opposite, that is the P over dB, that is adjacent side. And you are asked to express P. So to make P the subject of the formula, you cross multiply. So the answer is P equal to dB times tan X, just for 2 marks for the ratio and the answer for P. Okay, 6.1.2, we are going to prove that P. So here we already found P. Now we are going to prove that P is this big expression, which includes all the things in the second triangle, y, theta, k, everything. So that means now we are going to concentrate on in the bottom triangle. So in triangle DBC, how can we find P using the triangle DBC? So but there is already a connection point. P is dB times tan. We already have this. So let us use this triangle now to get the value of P. Okay. So when we are here in this triangle, when you look at the triangle, you have two angles and one side. So what we are going to use, two angles and one side. That means we are going to use the sine rule. Normally 70% or 80% of the questions we use sine rule. Okay, 6.1.2, let me answer it this side, then we can use the space to answer 6.1.2. 6.1.2. If you are using sine rule, start with the side that you are going to find. We are going to find dB, which is an unknown side we don't know, and which is a common side to both triangle. dB over sine, the angle opposite dB is theta, so it's dB over sine theta. You must know very well how to use the sine rule. So we take this side over the angle opposite, then we are going to use the side that is known, which is k, over what is the angle opposite here, which is angle B. We don't have the size of angle B, so now our aim is to find what is angle B. B means angle DBC. I'm going to find what is angle DBC. Before I continue, we already have the other two angles, so the third angle in that triangle is 180 minus y plus theta. Okay, so now we can substitute in here. Therefore dB, okay, let me also cross multiply here, k times sine theta, and when I am cross multiplying, in the denominator sine B, which is dBc, can be written as sine 180 minus y plus theta. That is a reduction formula, but we know sine 180 minus any angle is sine of that angle. So that means next step, it's k times sine theta divided by sine y plus theta. Now you are asked to find P, but in 6.1.1 we already found that P equal to dB times tan x. So let's come to this question now. Prove that P equal to, so we are going to use that answer we got in 6.1.1, which is P equal to dB tan x. And we now know what is dB. This is the dB now. dB is k sine theta divided by sine y plus theta. Let us substitute. That is k sine theta divided by sine y plus theta times tan x. But when you look at the answer, if there is a k sine theta tan x, but denominator is actually is an expansion of this compound angle formula. So that is only what is left now. We can use the compound angle formula to expand the denominator. So that means we can say this is k sine theta tan x on top, and the denominator just the expansion remaining, that is sine y cos theta plus cos y sine theta. We finished. We were able to show that P is this. So that is the 5-mark question, 6.1.2. Now 6.2, find BC to the nearest meter. So that's an important information, nearest meter. That means you must conclude your answer to the nearest meter now. If x equal to 51,7, y equals, so all the values are given here for the unknowns, x, y, k, all that, p, all that. Okay, so we are going to find the BC. So let's see whether we are going to use sine rule or cosine rule. We have the value of k, yes, it's here. We have the value of y is one side angle, and we can also find the dB because dB is this one. We just have to substitute the values of, no, we don't have theta, so I think we must use this one to get the value of dB. So let us start by finding the value of dB. I think that will work here. 6.2, let's find dB using the equation that we found in 6.1.1, that is P equal to dB tan x, because we have the value of P and we also have the value of x, so that's why we used it. So from this equation, what is dB? dB is therefore P over tan x. We made dB the subject of the formula. Now we are going to give the values of P, which is 80 over tan 51,7, which will give you 63,18. When you put this in the calculator, you will get 63,18 meters. So we found the value of B already. Okay, now, so that means in this triangle, now you have one side, this other side, and the angle included. You can use a cosine rule to find B's. So before we find the cosine rule, let me write the formula for you to understand how we are using the cosine rule here. BC square equal to, you start with the side we are finding, it will be equal to the other square of the other two sides, dB square plus DC square minus 2 times dB times same side DC times cos of the angle between the two, which is y in this case. This is how we use the formula. Now only substitution remaining. Therefore, BC equal to square root of, let us substitute, dB is 63,18 square plus DC is K is 95 square minus 2 times 63,18 times 95 times cos y. Y is 62,5 degree. Okay. Put everything in one step in the calculator and you will get 86,45, but to the nearest meter. So the nearest meter is 86 meters. That is the final answer. I hope you understand. If you have any questions, write your questions in the comment box. And if you understand, please subscribe to my channel, like and share. Thank you very much.